Welcome back, students. This is the Q&A session 5 from the chapter of motion in a straight line. And the question here is, a body is thrown vertically upward. When the air resistance is taken into account, the time of ascent is T1 and the time of descent is T2. So which of the following relation is correct? So there are four relations here, that is T1 is equal to T2, second one is T1 is less than T2, third one is T1 is greater than T2, and the fourth one is T1 is greater than equal to T2. So let us try to understand this question with the help of a simple diagram. So this is the ground, this is the surface, and now a body is thrown vertically upward. The body is thrown vertically upward, that is in this direction. Now here it is written that the air resistance is taken into account. That is, there is some air resistance, and air resistance is also known by the name of drag. Now air resistance is also known by the name of drag, and so in this case, when the air resistance is taken into account, the time of ascent is T1. Time of ascent means that is it is going in this upward direction and it will be reaching a certain height. Okay, na? It will be reaching a certain height and thereafter it will be coming downward. So the time of ascent is equal to T1 and the time of descent is T2. That is, it reaches a height, say a certain height in time T1, and then it comes, it starts coming down, and the time of descent is T2. So in this case, the first important thing which we should know is that this air resistance or the drag force, air resistance force or the drag force always acts in the opposite direction of motion. Air resistance or the drag force always acts in the opposite direction of the motion. That is, if the object is moving upward, then in that case, if the object is moving in this direction, that is, this is the upward direction, then the drag force or the air resistance, that is the force due to the air resistance, will be acting in the downward direction. So, and when this body is coming down, okay, during when it is coming down, then in that case, this air resistance or the drag force, it will be acting in the upward direction. So the air resistance or the drag force always acts in the opposite direction of motion. So this is the concept which we will be using in order to solve this question. So in the upward motion, when the body is moving in the upward direction, the net acceleration of the body will be equal to what? When this body is going in this upward direction, the drag force or the air resistance force will be acting in the downward direction. So we can say that the net acceleration will be equal to, now when it is going in the upward direction, the acceleration due to gravity is acting in the downward direction. So it is experiencing the g, that is the acceleration due to gravity will be acting in this direction, and as well as this drag force will also create an acceleration in the downward direction, but is because it is acting in the this downward direction. Now before calculating this net acceleration, let us consider that this drag force which is exerted on this body is equal to F. So if the mass of the body, let us consider the mass of the body, is equal to m, then because of this drag force, the acceleration which will be generated in the body will be equal to F by m, and also the acceleration due to gravity is g. So the net acceleration when the body is moving in the upward direction will be equal to F by m plus g, because both these two accelerations, they are acting in the same direction, that is in the downward direction. So the net acceleration on the body in the downward direction this will be equal to F upon m plus g, where F is the magnitude of the drag force and m is the mass of the body. Now let us come to the next point, that is we have to find the net acceleration of the body when it is coming down. So the net acceleration of the body in the downward direction is equal to F upon m plus g. So I will be writing this value here. That is the net acceleration in the upward motion is equal to g plus F divided by m. This is the net acceleration in the when the body is traveling in the upward direction. Now in the case of the downward direction, net acceleration of the body will be equal to, see, when it is moving down, the acceleration due to gravity is acting in the downward direction, but the acceleration due to this drag force, because when the body is moving downward, the drag force will be acting in the opposite direction, that is in this direction. This is the direction of the drag force in the case when the body is coming down. And so in this case, the net acceleration of the body will be equal to g. This g is acting, the acceleration due to gravity is acting in the downward direction, that is in this direction, and the acceleration due to the drag force is acting in the upward direction. So g is acting down and the acceleration due to the drag force is in the upward direction. So it will be the net acceleration on the body in the when the body is coming down will be equal to g minus F by m. Okay, so this is the net acceleration of the body in the when the body is coming down. So these are the two values which we have got. So net acceleration in the downward direction, is equal to g minus F divided by m. So in this case, we can see that the net acceleration in the upward motion, that is net acceleration in the upward motion in the upward motion of the body is equal to is, you can see here, it is greater than the net acceleration in the downward motion, that is when the body is coming down. So the net acceleration in the upward motion is greater than the net acceleration in the downward direction. So it implies that the time of ascent will be less than the time of descent. Okay, because the acceleration is since net acceleration in the upward direction is more than the net acceleration in the downward direction, therefore the time of ascent will be less than the time of descent, because the net acceleration in the upward direction is more than the net acceleration in the downward direction. So now here the time of ascent is given as, it implies that is given as T1. So T1 will be less than T2. So our correct option is B, that is T1 is greater than T2. So in this case, the most important thing which you have to remember is, that is the air resistance or the force due to the air resistance, or which is also called by the name of drag force. This drag force or the force due to the air resistance always acts in the opposite direction of motion. That is, when the body is moving in the upward direction, then the drag force will be acting in the downward direction, and when the body is moving in the downward direction, then the drag force will be acting in the upward direction. So based on this concept, I was able to calculate the net acceleration in the upward direction, which was equal to G plus F by M, where F is the magnitude of the drag force or the force due to this air resistance, and M is the mass of the body, and which was equal to G plus F by M, and the net acceleration in the downward direction was equal to G minus F by M. Since the net acceleration in the upward direction is more than the net acceleration in the downward direction, therefore the time of ascent, that is, will be time of ascent means the time taken by this body to reach this highest point during the motion in the upward direction. So the time of ascent will be less than the time of descent. So thank you very much for joining this session. That is session number 5, and in the next session I will be coming up with another good question. And so till then, have a nice day. Bye.